Good morning, guys. Anjani Kumar here, dealing Power System 2 for third year electrical students. Right? So, we are continuing our lecture on what are the various factors that are affecting the transmission system. Right? So, in this, we successfully completed the concept of skin effect. So, what is a factor of a skin effect? After that, we discussed about proximity effect. Alright, so after that, we discussed about Ferranti effect. Right? Now, we are going to discuss about very important concept. So definitely in your real life also you will see these type of effect. You will observe these type of effects in a transmission system. So that is called corona effect. Right? So I think it's unfortunate, right? You know how the corona pandemic, how it is affecting the whole world. You are seeing in your life, in your present days. But it's very fortunate that I am going to discuss about the corona concept, how it is happening in a transmission system. Right? So both are interlinked. So that will be a one of the effects, and this corona that what we are now fearing. So this is also the effect, right? It's very unfortunate for us to discussing about corona concept in these corona days, right? In this corona effect, so first let me explain what are the things that we need to discuss, right? So here corona effect. So presently, first we will discuss about what is a phenomena. So what is a phenomena of corona? Right? So how the corona discharge will form? How corona discharge will form? How the corona will form? Right? We'll discuss about in detail. After that, what are the factors that affects the corona? Right? So after that, we discussed some important terms. Right? Corona is nothing but a problem. So if you want to design your transmission system, so we need to build your transmission system with reduced corona. Right? So on what basis you should reduce this corona? So we need to know some important terms regarding our design of a transmission system. Right? If you want to design your transmission system, definitely you should avoid this corona effect in a transmission system. Right? So for this we need to know some important terms. So while considering design of a transmission system, so what are the terms? We'll see critical, visual, descriptive voltage, critical descriptive voltage, and power loss. Right? So these are the important terms that we need to discuss while discussing about the corona. And after that, we discussed about what are the advantages. Definitely the corona will make some advantages also. Alright, advantages and disadvantages. Alright, so after that we discuss about methods to reduce a corona. Reduce. So these are the flow what we are going to discuss under the concept of corona. It's very understandable, and it's very easy and useful concept while studying your power system, transmission system, and all these things. Right? So in this we are going to discuss about what is the phenomena of corona, how the corona discharge, how the corona will form in a transmission system. After that, what are the factors that are affecting the corona, and some important terms while designing your transmission system to avoid a corona. So that is a visual descriptive voltage, with critical descriptive voltage, and some power loss conditions that we need to know. After that, advantages and disadvantages of corona, and how the methods to reduce the corona in order to make efficient power system, efficient transmission system. Hope it's clear. Now we are moving to the original concept called corona. So corona effect. Alright. So first we need to know the phenomena. So after that we will discuss how the corona will happen. Alright. The phenomena of violet low, ozone gas, and some hissing noise. In an overhead transmission system. So we can call it corona, right? So what is a corona? Corona means the phenomena states that the formation of violet glow, ozone gas, and some hissing noise, so that are developed in an overhead transmission system. If you observed this type of concept in an overhead system, thus phenomena, how that we can call it as a corona. So that phenomena we can call it as a corona. So that effect we can call it as a corona effect. Right? So I'll explain one more time. The phenomena of how the violet glow and some hissing noise and ozone gas is forming around a conductor or in a conductor in a transmission system, so we can call it as a corona. Right? So we'll see how the corona will form. Right? If we have a two conductors which are large distance, right? So there are two conductors, that is nothing but two transmission towers which are placed in a large distance. So the air between the two conductors has a dielectric medium, right? So in this large distance, we don't have any effect on the air. So we don't have any effect on the air. Alright? So if you apply a voltage, alternating voltage between the two conductors, there is no effect of corona. Right? There is no effect of corona. Right? Now, when two conductors which are closely spaced, because this is very crucial situation for us. Why? Because if you are placing a conductors which are large distance, definitely it will be a cost based issue. Right? At the towers which are built some sort of height towers required, some sort of distance means we need to more towers are going to be inserted, right? So these are most cost based issue, right? So we are developing our transmission system means it should be a costless and more efficient, right? That means if the two conductors which are placed in a large distance, definitely there will be no effect of a dielectric constant which is between the two conductors. So we can call it as air is a dielectric medium, right? So we don't have any effect on the air. So that means we don't have any that much concept of corona. There is no concept of hissing noise. There is no concept of violet glow. Right, all these things, right? Now we'll see if the two conductors which are placed closely placed, this is very more advantageous for us, right? Now, so here air is a dielectric medium. See, air is a dielectric medium. So right, so when you apply a high alternating voltage applied across a conductor, so definitely the dielectric strength of air will break down. How it will break down, we'll see. The function that I'm saying, right? So when two conductors are closely placed, so what happen if you apply a high voltage? So definitely the corona will happen greater than 33 kV, because the large voltage transmission system only these type of effects will consider, right? So if you have conductors which are closely spaced, right, so what happen if you apply a voltage? Definitely the dielectric constant of air will break down, right? So breakdown happen means air got ionized. So what happen? It will make a conducting part. So in that situations the corona will form. I hope it's clear. How the dielectric breakdown occurs, we will discuss, right? So when the corona form means if the system which is having high voltage transmission, if the conductor space is very less, so what happen if you high voltage that applied across the conductors, definitely there will be the breakdown of air. There will be a ionization of air. Due to that ionization, there will be a conducting path between these two conductors. So this will form a hissing noise. This will form violet glow. Right? So these type of things we can call it as a corona. I hope it's clear. I think I just want to explain one more time. The phenomena states that the violet glow, hissing noise and ozone gas that are developed over a transmission system which is carrying high voltages, right? So these phenomena we can call it as a corona. But suppose if you are taking a conductors which are large distance, so there will be an air which is as a dielectric medium between the two conductors, right? So under these large distance situations, right, when you apply a potential difference, applied a voltage, definitely there will be a no breakdown of air. How it will happen, we'll see. There is no concept of corona here. So when two conductors which are closely spaced, right, so definitely when you apply a large voltage potential difference between the two conductors, so what happened? The air got ionized. That means the dielectric strength of air, there will be a breakdown happens. So the air will act as a conducting path, will make a conducting path. Air actually insulator, right? So when it crosses it over dielectric strength, actually the air dielectric strength is 30 kV per centimeters, right? If this voltage crosses, so definitely the air will act as a conductor. That means between these two conductors, the air made as a conductor means there will be some sort of issue will be created. So that issue, that noise, so that glow, we can call it as a corona. I hope it's clear. Right? I just want to explain how the corona will form. Right? So you have a clear idea. So when the corona form means corona form when high voltage transmission system greater than 33 kV. The corona will form, right? So when the corona will form means breakdown of air, right? So these two things we need to know. Now we'll see. Right? So this is a transmission lines. Clearly listen. This concept is very, very important, and it should be very understandable also, right? So this is a conductor 1 and conductor 2, right? So between these two conductor, air is there, right? So this air will act as an insulator between the two conductors, right? So the dielectric strength, so at what point, at what voltages this will make as a insulator. If it crosses, it act as a conductor also, right? So dielectric strength of air is 30 kV per centimeters. So whatever the insulating medium air is there na, so the dielectric strength of this air is 30 kV per centimeters, right? If it crosses, what happen? The air will also as a conductor, right? That's we need to understand, right? Now these conductors which are carrying high voltages, per suppose high voltages means when a conductor carrying high voltages means it provides potential gradient around the conductor. We'll see how the potential gradient happening means. Per suppose if the conductor is carrying 400 kV line, right? So how the potential gradient happening means, per suppose if this is a conductor na, so conductor which is having different layers, right? How it can carry 400 kV volts means, so for a distance variations your voltage will change on the surface of the conductor which is having a maximum amount like 300 kV here, right? And for a distance reduces, here you will get 250 kV, right? Here you will get 100 kV, right? Here you will get 50 kV. Like that, the potential is going to be distributed over the surface, over the conductor. So that's potential distribution. So we can call it as a potential gradient. We'll discuss another unit is there. Performance of a transmission lines. In that you will clearly understand the potential gradient concept. See, while the conductor is carrying a 400 volts means how it can make means the conductors which surface of layer which is having a surface which is having more voltages, right? So the potential gradient which is very high under the surface of the conductor. Hope it's clear. So 400 kV ni pass chestundante how it will be distributed means on the surface you will get around 300 kV. If a distance reduces, your potential gradient also reduces. That means 400 kV, 300 kV, 100 kV, 50 kV, like that the potential gradient will distribute, right? For suppose if it is a 400 kV transmission system. Alright, now I am assuming that greater than 33 kV each and every line you will get the concept of corona, right? Now 400 kV line is passing, so definitely what happened, there will be a potential gradient will be developed. You just listen, that potential gradient will be there, right? Here also the potential gradient will be there, right? Now you will consider this is a free space now, the air which is acts as an insulator here, right? And throughout the air we have some some electrons will be placed due to the cosmic rays or X-rays, whatever it may be, cosmic ray, radiation. Some free electrons will be there. In this air, you will have some air molecules, right? Air molecules, that means several atoms clubbed together. Air molecules are going to be present. Right? In the air, several air molecules are present. Right? And some free electrons is there. Right? Some free electrons and air molecule will present. Hope it's clear. Now your 400 kV transmission, 400 kV line passing the current, and there will be a potential gradient will be developed. That means the surface of the conductor which is having a maximum stress. Alright. Now initially these electrons, initially the free electrons which exist between the two conductors doesn't have any velocity. Right? Doesn't have any velocity to move and collide with the air molecules. Right? Some few electrons will be there. Whenever you apply a high voltage, the definitely potential gradient will increases. That means here you will get the 300 kV voltage. That means how much voltage? That much voltage is developed near the surface of the conductors. So definitely here also electrons will be there now. Right? If that much voltage appears, means these electrons will get some velocity near the surface of the conductor. So when these electrons got the velocity, then directly it will collide the molecules in the air. So what happened? What happened? These electrons will move and collide with the air molecules. ఎప్పుడైతే ఎయిర్ మాలిక్యూల్స్తో కొలైడ్ అవుతుందో దెన్ డెఫినెట్లీ అగైన్ సమ్ ఎలక్ట్రాన్స్ అండ్ ions will be developed. Again, ఎప్పుడైతే హిట్ చేస్తుందో అగైన్ సమ్ ఎలక్ట్రాన్స్ డెవలప్. Again, these electrons will collide with another air molecule and develop another electrons. Likewise, in this portion, fill up with electrons. Right? So when this portion fill up with electrons means it makes a conducting path. Right? There will be a charge will be placed between these two. Right? So up to at what strength means up to the dielectric medium 30 kV per centimeters, up to that it will act as an insulator. Some electrons are going to be formed like that. If it crosses, definitely the total electrons will be placed between the two conductors. Right? How much these place filled with electrons means there will be a conduction path. So definitely what happens, some hissing noise will be developed. Right? Some glow will be developed because there will be a charge from here to here will transfer. So there will be a violet glow will develop. So this concept, so that hissing noise when electrons flow from top conductor to bottom conductor, you will get some noise will be present. So that means the movement of electrons, right? Large voltage transferring, large force on the electrons, large electrons will hit the air molecules. Definitely the molecule will be divided and then definitely they will develop the electrons and ions. Then electrons again hit the air molecules and develop the electrons. Like this, the space between the two conductors fills with the electrons. That means air got ionized. Right? So that means there will be a their air got some breakdown. Right? It will act as a conductor here. Then definitely what happened? There will be some hissing noise and some violet glow will be developed. So that hissing noise and violet glow, it also developed the ozone gas. So that we can call it as a corona. I hope it's clear. So that concept, that forming of hissing noise and violet glow, we can call it as a corona. Alright? You will see near the transmission system in our college, when you close to the transmission system, I think it's carrying 132 kV. So there is a power grid. So nearby మన కాలేజీకి దగ్గరలో ఒక ట్రాన్స్మిషన్ లైన్ వెళ్తూ ఉంది. సో ఐ థింక్ దట్స్ 132 kV. ఇఫ్ యూ క్లోజ్ టు దట్ ట్రాన్స్మిషన్ సిస్టమ్, డెఫినెట్లీ విల్ గెట్ సమ్ నాయిస్, రైట్? like that, like so that noise we can call it as a corona. Hope it's clear how the corona will form, right? So if not, I'll clearly explain. See, this is the two conductors, so which are closely spaced, right? When high voltage are transferring, so the air is dielectric medium between the two conductors, right? So when high voltage that you apply, definitely the potential gradient will develop. So the potential gradient developing means on the surface of the conductor you are getting a maximum stress, right? So before there will be a free electrons and ions will be present between the conductors. Air molecules will be there and some free electrons and ions will be there. Electrons, how the free electrons means due to the cosmic rays in the air, right? So whatever the some radio interference signals, so due to that some electrons will be there. So then what happened, these electrons doesn't have any that much force to collide with the air molecules, right? So the air which is having air molecules, ఎప్పుడైతే you are developing your high voltages on the surface of the conductor, you are getting a maximum stress. That means whatever the electrons near the surface which are jump to the air medium, that means the flow of electrons, the velocity of electrons will be increases, the force will increases. Due to the force, these electrons will collide with the air molecules. Then what happened, the molecule will divide and develop another electron and ions, and again that electron will collide with another molecules, then it will develop another electron, another ion. So it's a cumulative process. With this, the spacing between the two conductors which are filled with electrons, so that means your air got breakdown, air got ionization, right? The dielectrics got a breakdown and the air will make as a conducting path, so between the two conductors. So this formation, then we will get some violet glow, right? Then violet glow, and some when the electrons flows between the two conductors, there will be some noise you will get. So that noise and then violet glow, some ozone gas also developed between the two conductors. So this phenomena on the overhead transmission system, we can call it as a corona. I hope understand, right? If the voltage is very less, means whatever the potential gradient which is developed, which is very less, so that means the electrons doesn't get any force. Due to that, the air breakdown doesn't occur. So that way it can be used for the large voltages only. I hope it's clear. Alright, so how the potential gradient developed means, so near the surface of the conductor which is having a maximum stress, that's why only near the surface of the conductor you are getting a maximum current, right? Because the potential gradient is very high over there, right? And the center of the conductor you are getting a very less value. Alright, this phenomena and in this way the air got ionization. This process, whole process, we can call it as a corona. Alright, hope it's clear how the corona will form. Alright, how the corona will form on overhead transmission system. Like your real life, you will observe high voltage transmissions. You just go to the high voltage transmission system, you will observe some hissing noise will be present. So those type of thing that you can call it as a corona. Right? So how the air breakdown, how the electrons will hit the air molecules, and again electron ions will be generated. It's like this, all the place will fill with the electrons. So when the space between the two conductors fills with the electrons, it will make as a conducting path from this to this. So some sort of hissing and violet glow will occur. So this phenomena we can call it as a corona. you will see in this video how the corona discharge will form, right? So you will see here, so there's the two transmission towers, right? How the corona discharge takes place means, see, so like this, how the air got break down over and some sort of arc will get over. This is the conducting part, so that should see how the corona discharge takes place.
That was cool.
Some sort of air drops break down there. You will find out there, right? So when two conductors are separated, the arc will be exist, right? So how it will form means that there will be a connecting path from that conductor to this conductor, right? See. So these are the different coronas, right? And the two conductors, there will be a breakdown. Because air got the dielectric strength, air got cross. Like this. Not only the transmission system, any high voltage conductor, when separating, see how the arc got formed. So there will be a conduction path, right? So in this way the corona will form. I hope it's clear. Nothing is there, right? How the corona form means, when high voltage transmission system, there will be a potential gradient. If it is a low voltage, whatever the voltage near the surface, which is very less, it is not sufficient to break down that air surround it, right? The voltage, so the minimum voltage that required to break down the dielectric strength of air, that voltage we can call it as a critical descriptive voltage, right? So visual, how the voltage, the minimum voltage at which the corona glow will be there, so that is called visual descriptive voltage, that we discussed in our next sessions, right? I hope it's clear about the concept of corona and all these things, right? In the next session we discussed about factors affecting the corona and some important terms that we are going to discuss. Thank you for now.